Picture this. You're standing in a vast empty room. The lights are dim, and you can barely make out the walls in the distance. But here's the thing. The room is getting bigger. Not because someone's moving the walls, but because the space itself is stretching, expanding, pulling everything apart. And the strangest part? It's accelerating. The expansion is speeding up, driven by something you can't see, can't touch, and can't even properly understand. Welcome to our universe, where 70% of everything that exists is made of something we've never directly detected, something we call dark energy. And it's not just sitting there quietly in the background. It's actively reshaping the cosmos, determining the fate of every star, every galaxy, every atom that will ever be. Now, I know what you're thinking. Dark energy sounds like something from a science fiction movie, right alongside warp drives and lightsabers. But here's the kicker. It's real, it's everywhere, and it's been hiding in plain sight since the beginning of time. In fact, while you've been watching this video for the past 30 seconds, dark energy has stretched the fabric of space itself by distances that would make your head spin. Here's what's absolutely mind-blowing. We live in a universe where the majority of its content is completely invisible to us. Imagine if 70% of your house was made of materials you couldn't see or feel, but you could tell they were there because doors kept opening by themselves and furniture kept rearranging when you weren't looking. That's essentially what dark energy is doing to our entire universe, every single second of every single day. But before we dive into this cosmic mystery, and trust me, we're going to explore some seriously wild territory together, let me ask you something. How comfortable are you with the idea that most of reality is hidden from your senses? Because by the end of this journey, you're going to discover that the universe is far stranger, far more dynamic, and far more mysterious than you ever imagined. And speaking of journeys, if you're the kind of person who gets excited about uncovering the deepest secrets of reality, if you're curious about the forces that shape the cosmos and continue to reshape it every moment, then you're in exactly the right place. Because we're about to embark on an exploration that will fundamentally change how you see the night sky, how you understand space and time, and how you think about existence itself. Now, I've spent years diving deep into the research, talking to cosmologists, and piecing together this puzzle that has baffled some of the brightest minds in science. What I'm going to share with you isn't just theory. It's a story that begins with one of the most shocking discoveries in the history of astronomy, and leads us to a universe that's far more alive and dynamic than anyone expected. But here's what makes this even more incredible. The discovery of dark energy wasn't just a small adjustment to our understanding of the cosmos. It completely shattered our assumptions about how the universe works. It was like thinking you understood gravity, only to discover that invisible hands are constantly pushing and pulling everything around you in ways you never noticed. So let me start with a simple question that will blow your mind. What if I told you that the empty space between stars, the vacuum that seems like absolute nothingness, is actually buzzing with energy? What if that empty space is not only filled with something, but that something is actively pushing the entire universe apart, faster and faster, with each passing moment? This is the story of dark energy, the universe's most mysterious force, and how its discovery forced us to rewrite everything we thought we knew about reality. Let's go back to 1998. Picture the scene. Teams of astronomers around the world are using the most powerful telescopes available to study distant supernovas, exploding stars that are so bright they can outshine entire galaxies. These researchers aren't just stargazing for fun. They're on a mission to measure how fast the universe is expanding, and more importantly, to figure out whether that expansion is slowing down. See, ever since Edwin Hubble discovered in the 1922nd that the universe was expanding, scientists had a pretty clear picture of what should be happening. The Big Bang had set everything in motion, sending matter flying outward in all directions. But gravity, that familiar force that keeps your feet on the ground, should be pulling everything back together, gradually slowing down the expansion. It's like throwing a ball into the air. No matter how hard you throw it, gravity will eventually slow it down, stop it, and pull it back. The big question was, how much is gravity slowing things down? Would the universe expand forever, but more and more slowly? Or would gravity eventually win, causing everything to collapse back in on itself in what scientists called the Big Crunch? These astronomers thought they were going to answer that question by measuring distant supernovas. These exploding stars are incredibly useful because they're what scientists call standard candles. They all explode with roughly the same brightness. So by measuring how dim they appear from Earth, you can calculate exactly how far away they are. And by looking at how their light is stretched by the expansion of space, you can figure out how fast they're moving away from us. The plan was straightforward. Measure lots of distant supernovas, plot their distances against their speeds, and you get a nice curve showing how the expansion of the universe has been slowing down over time. Simple, right? Except that's not what they found. Instead, when the results came in, something absolutely shocking emerged from the data. The distant supernovas weren't just moving away from us, they were moving away faster than expected. Much faster. The expansion of the universe wasn't slowing down at all. It was speeding up. Let me put this in perspective for you. Imagine you're driving down a highway and you take your foot off the gas pedal. You'd expect the car to slow down because of friction and air resistance, right? But instead, the car starts accelerating, faster and faster, with no explanation for what's pushing it forward. That's essentially what these astronomers discovered was happening to the entire universe. The implications were staggering. If the expansion is accelerating, then there has to be something pushing everything apart. Something with enough energy to overpower the gravitational pull of all the matter in the universe. Something that fills every cubic inch of space and never runs out of steam. They called it dark energy, and the name is perfect because it captures exactly how mysterious this force is. It's dark because we can't see it, can't detect it directly, and don't really understand what it is. But energy captures the fact that it's actively doing something. It's driving the expansion of space itself. Now, when I say this discovery was shocking, I mean it literally sent shockwaves through the scientific community. These weren't fringe researchers making wild claims. These were mainstream astronomers using established techniques, and their results were so unexpected that other teams rushed to verify them. And sure enough, independent observations confirmed it. The universe's expansion is accelerating, but here's where it gets even crazier. To drive this acceleration, dark energy has to make up about 70% of everything in the universe. Let that sink in for a moment. 70%. That means everything you can see, every star, every galaxy, every planet, every atom in your body represents less than 5% of what's actually out there. Think about that. You're living in a universe where the vast majority of its content is completely invisible and completely mysterious. It's like discovering that your house is mostly made of invisible rooms that you never knew existed, and these rooms are somehow causing your visible rooms to move farther and farther apart. And this isn't some distant abstract concept that only affects faraway galaxies. Dark energy is operating right here, right now, all around you. The space between your hands is being stretched by dark energy. The distance between Earth and the nearest star is growing because of dark energy. Even as you sit there watching this video, the fabric of space itself is expanding, carrying distant galaxies away from us at ever-increasing speeds. But what exactly is dark energy? That's where things get really interesting and honestly really frustrating for scientists. Because the truth is, we don't know. We can measure its effects, we can calculate how much of it there is, and we can predict what it's going to do to the universe in the future. But what it actually is remains one of the biggest mysteries in all of science. Some scientists think it might be a property of space itself, that empty space naturally contains energy that pushes everything apart. Others think it might be a new kind of field, similar to the Higgs field that gives particles their mass, but operating on cosmic scales. Still, others propose that our understanding of gravity itself is wrong, and what we're calling dark energy is actually just gravity behaving differently on the largest scales. The honest answer is that we're still figuring it out, and that's what makes this so exciting. We're living through one of the most important scientific discoveries in history, and we're still in the early stages of understanding what it means. But here's what we do know, and it's absolutely mind-blowing. Dark energy isn't just passively filling space, it's actively shaping the fate of everything that exists. Every star that will ever form, every galaxy that will ever evolve, every planet that will ever harbour life, all of it is being influenced by this mysterious force that we're only just beginning to understand. And the story gets even stranger when you realise that dark energy seems to be constant. Unlike matter, which gets diluted as space expands, dark energy maintains the same density everywhere. As the universe grows, more dark energy appears to fill the new space. It's like having a magic pitcher that automatically refills itself no matter how much you pour out. This means that as time goes on, dark energy becomes more and more dominant. In the early universe, when everything was packed closely together, matter and radiation were the main players. But as space expanded and matter spread out, dark energy started taking over. And in the far future, dark energy will be virtually the only thing left, driving galaxies so far apart that the night sky will go completely dark. But we're getting ahead of ourselves. Right now, we're living in what you might call the golden age of the universe, a time when stars are still forming, galaxies are still colliding and merging, and the cosmic dance is still in full swing. Dark energy is there, quietly working in the background, but it hasn't yet dominated completely. And that brings us to one of the most fascinating questions in all of cosmology. What does the future hold? If dark energy continues to accelerate the expansion of the universe, what will happen to everything we know and love? Will stars eventually burn out in isolation, separated by unimaginable distances? Will space itself tear apart, ripping atoms to pieces in what scientists call the Big Rip? Or is there something we're missing? Some deeper understanding that will change everything once again? These are the questions that keep cosmologists awake at night, and they're the questions we're going to explore as we dive deeper into the mystery of dark energy. Because understanding this invisible force isn't just about satisfying scientific curiosity, it's about understanding our place in the cosmos and the ultimate fate of everything that exists. The universe has surprised us before, and there's every reason to believe it will surprise us again. But right now, in this moment, we're living in a cosmos dominated by a force we barely understand. A force that's quietly but relentlessly reshaping reality itself. And that's just the beginning of our journey into the dark side of the universe. So here's where the story gets really wild. Because it turns out that dark energy isn't just some recent addition to the cosmic playbook. It's been there all along, quietly working behind the scenes since the very beginning of time itself. But for billions of years, it was like a sleeping giant, waiting for its moment to take center stage. Let me paint you a picture of how this cosmic drama has unfolded. Imagine the universe as a massive tug-of-war game that's been going on for nearly 14 billion years. On one side, you have gravity, the ultimate team player, trying to pull everything together, to create structure, to build galaxies and stars and planets. On the other side, you have dark energy, the mysterious force that wants to push everything apart, to create space, to drive expansion. And here's the fascinating part. They've been taking turns winning. In the early universe, right after the Big Bang, gravity was the heavyweight champion. Matter was packed so densely that gravitational forces dominated everything. Dark energy was there, sure, but it was like a whisper in a thunderstorm, completely overwhelmed by the sheer density of matter and radiation. During this era, gravity was busy doing what it does best, pulling things together, creating the first structures, setting the stage for everything that would come later. For billions of years, this cosmic wrestling match continued. Gravity would pull matter together to form the first stars, the first galaxies, the first clusters of galaxies. Meanwhile, dark energy just sat there, patient and persistent, like water slowly but steadily wearing away at a stone. It never got stronger, but it never got weaker either. And crucially, as the universe expanded and matter spread out, gravity's grip started to weaken. You see, gravity depends on how much stuff is packed into a given volume of space. As the universe grows and matter gets diluted, gravity's influence diminishes. But dark energy? Dark energy maintains the same strength everywhere, always. It's like having a force that never gets tired, never runs out of steam, never loses its edge. And somewhere around 5 to 6 billion years ago, right around the time our solar system was forming, the balance tipped. Dark energy finally became strong enough to overpower gravity on the largest scales. The expansion of the universe, which had been slowing down for billions of years, suddenly started speeding up again. Think about what this means. The universe you're living in right now is fundamentally different from the universe that existed when the first stars were born. Back then, gravity was winning the cosmic tug of war, pulling things together, creating structure. Now, dark energy is in charge, and it's pulling everything apart. But here's what's really mind-bending. We can actually see this transition happening when we look deep into space. Remember, when you look at distant objects in the universe, you're literally looking back in time. The light from those objects has been traveling for billions of years to reach us. So when astronomers study very distant supernovas, they're seeing what the universe was like when gravity was still winning the battle. And when they study closer supernovas, they're seeing what the universe looks like now that dark energy has taken over. It's like having a time machine that shows you exactly when and how the cosmic balance of power shifted. This isn't just abstract physics. This transition has profound implications for everything in the universe, including us. If dark energy had started dominating earlier, galaxies might never have formed. Stars might never have ignited. Planets like Earth might never have coalesced. The fact that we exist at all is partly due to the precise timing of when dark energy began to take control. We're living in what cosmologists sometimes call the Goldilocks epoch of the universe, not too early, when everything was too chaotic and hot for complex structures to form, and not too late, when dark energy will have pushed everything so far apart that the universe becomes cold and empty. We're living in the sweet spot, when the universe is old enough to have interesting structure, but young enough that things are still happening. But let's zoom out for a moment and talk about what dark energy actually does to the fabric of reality itself. Because this isn't just about objects moving through space. This is about space itself, changing, growing, evolving in ways that challenge our most basic intuitions about how reality works. When scientists say that dark energy is causing the expansion of space, they mean something very specific and very strange. They're not saying that galaxies are flying apart through empty space, like debris from an explosion. They're saying that the distance between galaxies is increasing because new space is being created between them. Imagine you have a balloon with dots drawn on it. As you inflate the balloon, the dots don't move across the surface instead. The surface itself stretches, carrying the dots along with it. That's what's happening to our universe, except in 3 dimensions instead of 2. Space itself is stretching, and galaxies are being carried along for the ride. Now, you might be wondering, if space is expanding everywhere, why aren't you expanding too? Why isn't the distance between your atoms growing? Why isn't your coffee cup getting bigger, along with the universe? The answer has to do with the relative strength of different forces. On small scales, the scale of atoms, molecules, even entire solar systems, other forces are much stronger than dark energy. Electromagnetic forces hold your atoms together. Gravity holds the solar system together. These forces easily overpower the weak but persistent push of dark energy. It's only on the largest scales, where other forces become negligible, that dark energy's influence becomes apparent. Individual galaxies aren't expanding. Even clusters of galaxies, held together by their mutual gravitational attraction, aren't expanding. But the space between widely separated clusters, that's where dark energy rules supreme. And here's something that might blow your mind. The expansion of space actually creates new energy as it goes. Remember how I said dark energy maintains the same density even as space grows? That means that as the universe doubles in size, the total amount of dark energy in it also doubles. It's like having a bank account that automatically adds money to itself as the economy grows. This seems to violate one of the most fundamental principles in physics, the conservation of energy. Energy is supposed to be conserved. It can change from one form to another, but the total amount should always stay the same. Yet dark energy appears to be creating itself out of nothing as space expands. How is this possible? Well, it turns out that when you include gravity in your calculations, energy conservation becomes much more complicated. The expansion of space actually stores negative gravitational energy, which exactly balances the positive dark energy being created. So the universe isn't cheating, it's just keeping its books in a way that's far more sophisticated than we initially realized. But let's talk about what this means for the future, because the implications are both fascinating and, frankly, a little bit terrifying. If dark energy continues to dominate the universe, and all our evidence suggests it will, then the future looks very different from the past. Right now, we live in a universe where gravity and dark energy are locked in this cosmic dance, with dark energy slowly gaining the upper hand, but eventually, dark energy will win completely. In the far future, galaxies will become isolated islands in an ocean of expanding space. The Milky Way and Andromeda will still collide. In about 4 billion years, they're close enough that their mutual gravity overcomes dark energy. But after that merger, our local group of galaxies will become increasingly isolated from the rest of the universe. Over trillions of years, the night sky will gradually go dark. One by one, distant galaxies will disappear from view as they're carried away by the expansion of space. Eventually, any civilization that exists in that far future will look up at the night sky and see nothing but darkness, no evidence that there are other galaxies, no cosmic microwave background radiation, no clues about the Big Bang or the larger structure of the universe. They'll be living in what cosmologists call a lonely universe, where each surviving galaxy exists in complete isolation, surrounded by empty, expanding space. And the story doesn't end there. If dark energy continues to accelerate the expansion, or if it gets stronger over time, we might be headed for something called the Big Rip. In this scenario, the expansion of space eventually becomes so violent that it tears apart everything. Galaxies, solar systems, planets, molecules, even atoms themselves. It sounds like science fiction, but it's a real possibility based on our current understanding of dark energy. The universe that began with the Big Bang might end with space itself expanding so rapidly that nothing can hold together. Of course, we're talking about timescales that are almost impossible to comprehend. The Big Rip, if it happens at all, is estimated to occur in about 22 billion years from now. That's longer than the universe has currently existed. So while it's scientifically fascinating to think about, it's not exactly an immediate concern. But here's what I find truly remarkable about all of this. We're living in the only epoch in the history of the universe when intelligent beings can actually figure out what's happening. We exist at the perfect time to discover the cosmic microwave background, to see distant galaxies, to piece together the story of the Big Bang and the role of dark energy. Civilizations in the far future won't have access to this information. The evidence will have been carried away by the expansion of space. In a very real sense, we're living in the universe's brief moment of self-awareness, the short period when the cosmos can understand itself through conscious observers like us. And that brings us to one of the most profound questions in all of cosmology. Why now? Why does dark energy seem to have started dominating the universe at roughly the same time that complex life was evolving on Earth? Is this just an incredible coincidence? Or is there something deeper going on? Some scientists have proposed what's called the anthropic principle, the idea that we observe the universe to have the properties it does because if it were different, we wouldn't be here to observe it. Maybe dark energy had to start dominating at exactly this time for intelligent life to evolve. Maybe universes where dark energy takes over too early or too late simply don't produce observers. It's a controversial idea, and not all scientists buy into it. But it raises fascinating questions about the relationship between consciousness and cosmology, between observers and the universe they're trying to understand. What's certain is that dark energy has fundamentally changed how we think about our place in the cosmos. We're not living in the static, eternal universe that people imagined for most of human history. We're not even living in the expanding but slowing universe that scientists expected to find just a few decades ago. Instead, we're living in a dynamic, accelerating, evolving universe that's dominated by a mysterious force we're only beginning to understand. And that force is quietly but relentlessly reshaping everything around us, determining the fate of every star, every galaxy, every possible future civilization. The universe is not only stranger than we imagine, it's stranger than we can imagine. And dark energy is just the beginning of that strangeness. So what exactly is this invisible force that's reshaping the entire cosmos? When scientists first discovered dark energy, they basically had three options. Either our understanding of gravity was completely wrong, our measurements were somehow flawed, or there was something out there that we'd never encountered before, something that defied everything we thought we knew about how the universe works. And here's the thing, after decades of research, triple-checking measurements, and building increasingly sophisticated instruments, we've confirmed that our measurements are solid. Gravity seems to work exactly as Einstein predicted on every scale we can test. Which leaves us with option 3. We're dealing with something genuinely new, genuinely mysterious, and genuinely mind-blowing. But when I say mysterious, I don't mean it in some vague, hand-wavy sense. Scientists have actually proposed several concrete ideas about what dark energy might be, and each one is more fascinating than the last. The first possibility is that dark energy is what physicists call vacuum energy, the idea that empty space itself contains energy. Now, this might sound crazy, but quantum mechanics tells us that even in the most perfect vacuum you can imagine, space is never truly empty. It's buzzing with virtual particles that pop into existence and disappear again in tiny fractions of a second. These quantum fluctuations should contribute energy to empty space. The problem is, when physicists calculate how much vacuum energy there should be, they get a number that's about 120 orders of magnitude larger than what we observe. That's not a small error, that's the difference between the mass of a proton and the mass of a galaxy, multiplied by itself several times over. It's been called the worst prediction in the history of physics. So either our understanding of quantum mechanics is fundamentally flawed, or vacuum energy gets cancelled out by something we don't understand, leaving behind just the tiny amount we observe as dark energy. Neither option is particularly comforting for physicists. The second possibility is that dark energy is a new type of field, something like the Higgs field, that gives particles their mass, but operating on cosmic scales. Scientists call this hypothetical field quintessence, named after the fifth element that ancient philosophers believed filled the heavens. Unlike vacuum energy, which would be perfectly uniform everywhere, quintessence could vary from place to place and could even change over time. Maybe dark energy was weaker in the past and is getting stronger now. Maybe it will change again in the future, completely altering the fate of the universe. Some versions of quintessence theory predict that dark energy might actually reverse itself someday, switching from pushing space apart to pulling it back together. In that scenario, the current acceleration would eventually slow down, stop, and reverse, leading to what scientists call the Big Crunch, the opposite of the Big Bang, where everything in the universe collapses back into a single point. The third possibility is even more radical. Maybe there's nothing wrong with our measurements or our theories. Maybe the problem is that we're assuming we live in a normal part of the universe. What if our observable universe, everything we can see out to the cosmic horizon, is just a tiny bubble in a much larger, infinitely vast cosmos? In this scenario, called the multiverse theory, our local patch of space-time might have different physical properties from other regions. Maybe dark energy is strong here but weak somewhere else. Maybe other regions have different values for fundamental constants, like the speed of light or the strength of gravity. We'd be living in a cosmic suburb that just happens to have the right conditions for matter, stars, and life to exist. It sounds like science fiction, but some of our best theories about the early universe actually predict that this kind of multiverse should exist. During the first fraction of a second after the Big Bang, space expanded so rapidly that different regions lost contact with each other, potentially developing different physical properties. If the multiverse is real, then asking, why does dark energy have the value it does, might be like asking, why is Earth the right distance from the Sun for liquid water to exist? The answer isn't that there's something special about our planet, it's that there are billions of planets out there, and we happen to live on one of the rare ones where conditions are just right for life. Similarly, there might be countless regions of the multiverse with different amounts of dark energy, and we find ourselves in one where the value allows stars and galaxies to form. But here's what's truly wild. We might actually be able to test some of these ideas, and the way we're going to do it involves some of the most ambitious scientific projects ever attempted. Right now, astronomers are building telescopes that will survey billions of galaxies, mapping out the large-scale structure of the universe in unprecedented detail. They're measuring how dark energy has affected the growth of cosmic structure over billions of years. They're looking for subtle changes in the expansion rate that might reveal whether dark energy is truly constant, or whether it's been evolving over time. One of the most exciting projects is called the Dark Energy Survey, which has been mapping hundreds of millions of galaxies to trace how dark energy has shaped the universe. Another project, the upcoming Euclid Space Telescope, will measure the positions and shapes of over 1 billion galaxies with incredible precision. These surveys are looking for something called baryon acoustic oscillations, sound waves that travelled through the early universe and left their imprint on how matter is distributed today. It's like cosmic archaeology, using the current arrangement of galaxies to reconstruct what happened billions of years ago. They're also studying something called weak gravitational lensing, where the gravity of dark matter and dark energy slightly distorts the shapes of distant galaxies. By measuring these tiny distortions across millions of galaxies, scientists can map out how both dark matter and dark energy are distributed throughout space. And here's something that might surprise you. We're also trying to detect dark energy in laboratory experiments. Some theories predict that dark energy fields might interact very weakly with ordinary matter under specific conditions. Scientists are building incredibly sensitive instruments to search for these interactions, looking for effects so subtle that they've never been noticed before. But perhaps the most mind-bending approach involves studying the fundamental nature of space and time themselves. Some physicists think that dark energy might be a clue that our understanding of gravity is incomplete, that Einstein's theory of general relativity, as successful as it's been, might need modification on the largest scales. These modified gravity theories predict slightly different patterns in how galaxies move and how light travels through the universe. By comparing extremely precise observations with theoretical predictions, scientists are testing whether gravity really works the same way on cosmic scales as it does in our solar system. What's fascinating is that we're living through what might be the golden age of dark energy research. Every few months, new observations provide fresh clues about this cosmic mystery. Sometimes they confirm our expectations, sometimes they surprise us, and occasionally they force us to completely rethink our assumptions. For instance, Recent observations have shown that dark energy seems to be remarkably constant over cosmic time. It doesn't appear to be getting stronger or weaker as the universe evolves. That's actually a pretty strong constraint on the theoretical models. Many quintessence theories predicted that dark energy should be changing, but the observations suggest it's been essentially constant for billions of years. This consistency is both reassuring and puzzling. It's reassuring because it means the future evolution of the universe is somewhat predictable. If dark energy stays constant, we can calculate what will happen over the next trillion years. But it's puzzling because perfectly constant dark energy is actually harder to explain theoretically than dark energy that changes over time. And here's something that keeps cosmologists awake at night. What if dark energy isn't constant? What if it's been perfectly steady for billions of years, but it's about to change? What if we're living right on the cusp of a cosmic transition that will completely alter the fate of the universe? Some theoretical models predict that dark energy could undergo phase transitions, suddenly switching from one state to another. It's like water suddenly freezing into ice. The transition happens rapidly once certain conditions are met. If dark energy underwent such a transition, it could either strengthen dramatically, leading to a big rip scenario where space expands so rapidly that it tears everything apart, or it could weaken or even reverse, potentially leading to a big crunch. The scary part is that we might have no warning. The transition could happen tomorrow, or it could happen in 1 trillion years, or it might never happen at all. We simply don't understand dark energy well enough to know for sure. But here's what I find absolutely remarkable about this whole situation. We're not just passive observers of this cosmic drama. Every observation we make, every experiment we conduct, every theoretical insight we develop brings us closer to understanding one of the deepest mysteries in the universe. And the implications go far beyond academic curiosity. Understanding dark energy might be the key to understanding whether our universe is one of many, whether the laws of physics are the same everywhere, and whether intelligent life like ours is common or incredibly rare on cosmic scales. Think about it this way. Dark energy is actively determining the ultimate fate of every atom in your body, every star in the sky, every galaxy in the observable universe. It's the force that will decide whether future civilizations have a cosmos full of stars to explore, or whether they'll inherit a cold, dark, empty universe where galaxies are separated by unimaginable voids. In a very real sense, dark energy is writing the final chapters of the cosmic story. And we're living right now in the brief moment when conscious beings can actually read those chapters as they're being written. But the story gets even stranger when you realize that dark energy might not be working alone. Remember, it makes up about 70% of the universe, but there's another invisible component that makes up about 25%, dark matter. And while dark matter and dark energy have completely different effects on the universe, they're both invisible, both mysterious, and both absolutely essential to explaining how the cosmos works. Together, dark matter and dark energy make up 95% of everything that exists. That means the atoms in your body, the earth, the sun, all the stars you can see in the night sky, all of that represents less than 5% of reality. We're living in a universe that's almost entirely made of things we can't see, can't touch, and don't understand. And yet, somehow, in this cosmos dominated by invisible forces, matter managed to clump together, stars managed to form, planets managed to coalesce, and life managed to emerge and evolve to the point where it can contemplate its own existence and try to understand the very forces that shaped it. That's not just scientifically remarkable, it's almost miraculous. The fact that you're sitting here right now, thinking about dark energy, represents the culmination of nearly 14 billion years of cosmic evolution in a universe dominated by mysterious forces that we're only just beginning to comprehend. And we're not done yet. The next decade is going to bring observations and experiments that could revolutionize our understanding of dark energy. We might discover that it's been slowly changing over cosmic time. We might find evidence for new physics that explains both dark energy and dark matter. We might even discover that our entire picture of the universe needs to be fundamentally revised. Or we might find that dark energy is exactly what it appears to be: a perfectly constant, perfectly uniform energy density that fills every cubic centimeter of space and will continue pushing the universe apart for trillions of years to come. Either way, we're living through one of the most exciting periods in the history of science, when our understanding of the universe is expanding almost as rapidly as the universe itself. But here's where things get really interesting. And I mean the kind of interesting that makes you question everything you thought you knew about reality. Because scientists have discovered that dark energy isn't just some abstract force operating on cosmic scales. It's having measurable effects right here, right now, in ways that would absolutely blow your mind if you really understood what was happening. Let me give you an example that will make this personal. The Andromeda Galaxy, our nearest major galactic neighbour, is currently speeding toward us at about 250,000 miles per hour. In roughly 4.5 billion years, it's going to collide with the Milky Way in what astronomers poetically call a galactic merger. But here's the thing: Andromeda is one of the last galaxies that will ever collide with ours. Every other major galaxy in our cosmic neighbourhood is already being carried away by dark energy at speeds that will eventually exceed the speed of light. Think about that for a moment. Right now, as you're watching this video, there are galaxies that are moving away from us so fast that their light will never reach future civilizations. We are literally watching parts of the universe disappear forever, one galaxy at a time. It's like standing on the shore and watching islands drift away into an ocean that's expanding faster than any ship could ever travel. But this isn't just happening to distant galaxies. Dark energy is operating everywhere, including in the space between your hands right now. The reason you don't notice it is because other forces, electromagnetic forces holding your atoms together, gravity keeping you anchored to Earth, are so much stronger on small scales that dark energy's influence is completely overwhelmed. It's like trying to hear a whisper during a thunderstorm. However, and this is crucial, dark energy never stops working. It's patient, it's persistent, and over cosmic timescales, it always wins. The space between your atoms isn't expanding now because electromagnetic forces are holding everything together. But in the far future, if dark energy continues to strengthen, even those bonds might not be enough. That's the big rip scenario. I mentioned earlier a future so distant it's almost meaningless to us, but theoretically possible if dark energy's influence continues to grow. Now, let's talk about something that might completely change how you think about the nature of reality itself. Because dark energy doesn't just affect how fast things move apart, it affects the very structure of space and time. And this leads us to one of the most mind-bending concepts in all of physics: the idea that space itself might be quantized, made up of discrete units so small that they make atoms look gigantic. Imagine if space weren't smooth and continuous like we experience it, but actually made up of tiny, indivisible pieces, pixels of reality, if you will. Some theories suggest that dark energy might be related to the properties of these fundamental units of space. In this view, the expansion of the universe isn't just about distances getting larger. It's about new units of space literally coming into existence between existing ones. It's like watching a digital image where new pixels keep appearing between the old ones, making the overall picture bigger without stretching the individual pixels. Except in this case, the pixels are the fundamental building blocks of space itself, and the image is the entire universe. This connects to something called the holographic principle, one of the most revolutionary ideas in modern physics. The principle suggests that all the information contained in a volume of space can actually be encoded on the boundary of that space, like a hologram. In other words, our three-dimensional reality might actually be a projection from information stored on a two-dimensional surface. Now, you might be thinking, okay, that sounds completely insane. And you're right, it does sound insane. But here's the thing, this isn't just wild speculation. The holographic principle has become a cornerstone of theoretical physics because it helps solve some of the deepest puzzles about black holes, quantum mechanics, and the nature of information itself. And dark energy fits into this picture in a fascinating way. If the universe is indeed holographic, then dark energy might be related to the information processing that's happening on the cosmic boundary, the edge of our observable universe. Every time space expands, new information needs to be encoded, and that process might be what we observe as dark energy. But let's step back from the theoretical deep end for a moment and talk about something more concrete, the tools we're using to study dark energy and how they're revolutionizing our understanding of the cosmos. Right now, scattered across the globe and floating in space, there are instruments so sensitive that they can measure distances to galaxies billions of light years away with precision that would make a Swiss watchmaker jealous. The Dark Energy Spectroscopic Instrument, or DESI, is mapping the positions of over 40 million galaxies and quasars to create the most detailed three-dimensional map of the universe ever made. What makes this particularly incredible is that DESI isn't just mapping where things are, it's mapping where things were at different times in cosmic history. Remember, when we look at distant objects, we're seeing them as they were when their light left them. So a galaxy that's 8 billion light years away appears to us as it was 8 billion years ago. By mapping galaxies at different distances, DESI is essentially creating a time-lapse movie of how dark energy has shaped the universe over billions of years. And the results are starting to come in. Early data from DESI has already revealed something unexpected. There are hints, and I emphasize hints, because we need more data to be sure that dark energy might not be perfectly constant after all. The observations suggest that dark energy might have been slightly different in the past than it is today. If this holds up under further scrutiny, it would be absolutely revolutionary. It would mean that dark energy is dynamic, evolving, potentially unpredictable. It would open up entirely new possibilities for the future of the universe and entirely new questions about the nature of this mysterious force. But even if dark energy turns out to be perfectly constant, the precision with which we can now measure its effects is staggering. We can detect changes in the expansion rate of the universe that are smaller than 1% over billions of years. We can measure the subtle ways that dark energy has influenced the growth of cosmic structure, the formation of galaxy clusters, even the temperature fluctuations in the cosmic microwave background radiation. This level of precision has allowed scientists to rule out many theoretical models of dark energy and narrow down the possibilities for what it might actually be. We're not there yet, we still don't know what dark energy is, but we're closing in on it with every new observation. And here's something that might surprise you. Some of the most important dark energy research is happening not with giant telescopes pointed at the sky, but in underground laboratories buried beneath mountains. Scientists are building incredibly sensitive detectors to search for interactions between dark energy and ordinary matter that might be too weak to have been noticed before. One approach involves looking for tiny changes in the length of laser beams as they travel through vacuum chambers. If dark energy interacts with photons even incredibly weakly, it might cause microscopic changes in the speed of light under certain conditions. These changes would be unimaginably small, smaller than the width of a proton compared to the distance to the nearest star, but modern instruments are becoming sensitive enough to potentially detect them. Another approach involves studying whether the fundamental constants of nature, things like the strength of electromagnetic forces, or the mass of electrons might be slowly changing over time due to the influence of dark energy. If they are, we might be able to detect these changes by comparing the light from distant quasars with laboratory measurements made today. These experiments represent a completely different way of studying dark energy, not by looking at its effects on the largest scales, but by searching for its influence on the smallest, most precisely measurable quantities we can access in the laboratory. It's like trying to detect the presence of an elephant by looking for the tiny vibrations its footsteps create in a spider's web. But perhaps the most exciting frontier in dark energy research involves something called gravitational waves, ripples in the fabric of space-time itself that are created when massive objects accelerate. We've only been able to detect gravitational waves for a few years, but they're already opening up entirely new windows into the universe. Here's why this is relevant to dark energy. Gravitational waves travel at the speed of light, but they're affected by the expansion of space as they propagate. By comparing gravitational wave signals with electromagnetic signals from the same cosmic events, scientists can measure how space has expanded over the time it took those signals to reach us. This provides an entirely independent way to study dark energy that doesn't rely on traditional astronomical observations. Even more intriguingly, some theories predict that dark energy itself might create gravitational waves under certain conditions. If we could detect these dark energy gravitational waves, it would be like finally hearing the voice of this mysterious force that has been silently reshaping the universe for billions of years. The next generation of gravitational wave detectors, including space-based instruments like LISA, the Laser Interferometer Space Antenna, will be sensitive enough to detect gravitational waves from cosmic events throughout the observable universe. They might even be able to probe the nature of space-time itself at the moment when dark energy first began to dominate the cosmic expansion. And this brings us to one of the most profound questions in all of science. Is dark energy telling us something fundamental about the nature of reality itself? Is it a clue that our understanding of space, time, matter and energy is incomplete in ways we haven't even imagined yet? Some physicists think the answer is yes. They argue that dark energy might be evidence for extra dimensions of space that we can't directly perceive. In these theories, our familiar three-dimensional universe is like a thin membrane floating in a higher dimensional space. Dark energy might be leaking into our universe from these extra dimensions, or it might be a manifestation of the geometry of the higher dimensional space itself. Other physicists think dark energy is telling us that the quantum vacuum, the seething sea of virtual particles that exists even in empty space, is far stranger and more active than we previously realized. Maybe the energy of the vacuum isn't cancelled out perfectly as we assumed, but instead leaves behind a small residue that we observe as dark energy. Still, others think dark energy is a sign that we need to completely rethink our understanding of time itself. Maybe time isn't uniform throughout the universe. Maybe it flows at different rates in different regions of space, and what we interpret as dark energy is actually just the universe trying to synchronize different temporal regions. These ideas sound like science fiction, but they're based on serious theoretical work by some of the brightest minds in physics. And here's the remarkable thing. Within the next decade or two, we might actually be able to test some of these ideas. The combination of increasingly precise astronomical observations, more sensitive laboratory experiments, and more sophisticated theoretical models is converging toward a moment when we might finally understand what dark energy really is. We might discover that it's something completely unexpected, something that forces us to rewrite the textbooks and fundamentally change how we think about reality. Or we might find that it's exactly what it appears to be, a simple constant energy density that fills space and drives the expansion of the universe. But even that would be profound, because it would tell us that the universe is fundamentally different from what humans assumed for most of our history. Either way, we're living through a scientific revolution. The discovery of dark energy has already changed everything we thought we knew about the cosmos, and the next chapter of this story is still being written. Every new observation brings us closer to understanding this cosmic mystery, and every theoretical breakthrough opens up new possibilities for what dark energy might be and what it might mean for the future of everything. And here's what I find most remarkable about this entire situation. We're not just studying dark energy, we're living inside it. Every breath you take, every step you walk, every thought you think is happening in a universe that's dominated by this mysterious force. You are embedded in the very phenomenon that you're trying to understand. That's not just poetic, it's scientifically significant. Because if dark energy is truly a fundamental property of space itself, then understanding it might be the key to understanding consciousness, life, and the emergence of complexity in a universe that seems designed to tear everything apart. Think about it. In a universe dominated by dark energy, where space is constantly expanding and matter is constantly being diluted, the fact that stars form, planets coalesce, and life emerges is almost miraculous. It's as if the universe is engaged in a constant battle between the forces that create structure and complexity and the forced dark energy that wants to smooth everything out into cold, empty space. And somehow, in the middle of that cosmic battle, you exist, thinking, wondering, trying to understand the very forces that shaped the universe and will ultimately determine its fate. That's not just scientifically fascinating, it's profoundly meaningful on the deepest possible level. We're not done with dark energy's secrets yet, because there's another layer to this story that's going to completely reshape how you think about the relationship between space, time, and the very fabric of existence itself. And it starts with a question that sounds simple but opens up a rabbit hole that goes deeper than you might imagine. What happens to information in a universe dominated by dark energy? Now, I know what you're thinking. Information? What does that have to do with cosmic forces and expanding space? But stick with me here, because this is where dark energy research intersects with some of the most profound questions about the nature of reality itself. In physics, information isn't just data on a computer or words in a book. It's something much more fundamental. Every particle in the universe carries information about its position, its momentum, its spin, its history. When particles interact, they exchange information. When stars form, when planets evolve, when life emerges, all of these processes involve the creation, transformation, and preservation of information. And here's where it gets really interesting. In a universe that's expanding due to dark energy, information doesn't just sit there passively. It gets stretched, diluted, and potentially lost as space grows and objects move farther apart. Imagine trying to have a conversation with someone while the distance between you is constantly growing. Eventually, your words would become so faint and spread out that they'd be impossible to hear. Something similar happens to information in our expanding universe. The cosmic microwave background radiation, that faint afterglow of the Big Bang, is getting redder and dimmer as space expands. Eventually, it will fade away completely, taking with it crucial information about the early universe. Future civilizations won't have access to this cosmic baby picture that tells us so much about how everything began. But it gets even stranger when you consider quantum information. In quantum mechanics, particles can become entangled, connected in ways that seem to defy our normal understanding of space and time. When two particles are entangled, measuring one instantly affects the other, regardless of how far apart they are. Einstein famously called this spooky action at a distance, and it's been confirmed by countless experiments. Now, here's the mind-bending part. Dark energy is constantly stretching space, carrying entangled particles farther and farther apart. What happens to their quantum connection as the distance between them grows? Does the entanglement survive the expansion of space? Or does dark energy gradually break these quantum connections, destroying information in the process? Recent theoretical work suggests that dark energy might actually be intimately connected to the way information flows through the universe. Some models propose that the expansion of space creates new quantum entanglements while destroying others, leading to a constant reshuffling of information on cosmic scales. It's like the universe is playing a giant game of cosmic telephone, with dark energy controlling how clearly the message gets transmitted. This connects to something called the information paradox, one of the deepest unsolved problems in physics. The paradox arises when you consider what happens to information when it falls into a black hole. According to quantum mechanics, information can never be truly destroyed. But according to general relativity, anything that falls into a black hole is gone forever, crushed into a singularity where the normal laws of physics break down. Dark energy adds another layer to this puzzle. If space is expanding and information is being diluted, what happens to the fundamental principle that information must be conserved? Some physicists think dark energy might be nature's way of creating new information to replace what's being lost to cosmic expansion. Others think it might be revealing that our understanding of information conservation is incomplete. But let's zoom out from these abstract concepts and talk about something that might hit closer to home. What does dark energy mean for the long-term survival of intelligence in the universe? Think about it this way. Every civilization that has ever existed or ever will exist has to deal with the fact that they're living in a universe dominated by dark energy. Right now, we're in what you might call the easy era of cosmic history. Stars are still forming, galaxies are still merging, and there's plenty of energy available to power complex processes like life and intelligence. But as dark energy continues to drive the expansion, the universe is going to become a much more challenging place to maintain complex structures. Galaxies will become isolated islands in an ocean of expanding space. Stars will burn out and won't be replaced. The temperature of space will continue to drop, approaching absolute zero. In this far future universe, any surviving civilizations will face unprecedented challenges. How do you maintain communication across a cosmos where your nearest neighbors are being carried away by the expansion of space? How do you access energy when all the easily available sources have been exhausted? How do you preserve knowledge and culture when the very medium for storing information, matter itself, is becoming increasingly sparse? Some scientists have speculated about what they call cosmological engineering, the idea that sufficiently advanced civilizations might be able to manipulate dark energy itself. Maybe they could create local regions where the expansion is slowed or even reversed, allowing them to maintain oases of structure in an otherwise expanding cosmos. Maybe they could harness the energy of expansion itself, using dark energy as a power source for unimaginably vast projects. It sounds like science fiction, but the physics isn't necessarily impossible. If we ever figure out what dark energy actually is, we might discover ways to influence it, control it, or at least work with it, rather than being passive victims of cosmic expansion. And this brings us to one of the most important questions for our own species. Should we be worried about dark energy? Is this something that should influence how we think about our future, our priorities, our place in the cosmos? The honest answer is that dark energy operates on timescales so vast that it's not a practical concern for human civilization. The sun will burn out in about 5 billion years, long before dark energy's effects become locally significant. Our galaxy will collide with Andromeda in 4.5 billion years, completely reshaping our cosmic neighborhood. Climate change, asteroid impacts, and dozens of other challenges will affect humanity long before we need to worry about the expansion of space tearing apart our local environment. But in another sense, dark energy should absolutely influence how we think about our place in the universe, because it reveals that we're living in a cosmos that's far more dynamic, far more temporary, and far more precious than we ever realized. The universe isn't a static stage where the drama of existence plays out unchanged for all eternity. It's a living, breathing, evolving system that's constantly changing. The night sky you see today is different from the one your ancestors saw, and it will be different from the one your descendants see, if they're lucky enough to have a night sky to observe at all. This temporal perspective, this awareness that everything is temporary, including the large-scale structure of the cosmos itself, should make us appreciate what we have right now. We're living in the brief cosmic moment when stars are shining, galaxies are visible, and complex structures like planets and life can exist. We're witnesses to a universe in its prime, before dark energy drives everything into cold isolation. But there's another way to think about this that's actually quite hopeful. The discovery of dark energy has revealed that the universe is far more complex and surprising than we ever imagined. Just a few decades ago, we thought we understood the basic story of cosmic evolution. Matter clumped together due to gravity, stars formed, galaxies evolved, and everything slowly wound down due to entropy. Now we know that 70% of the universe is made of something we've never encountered before, something that's actively reshaping reality on the largest scales. We've discovered that the cosmos is not winding down, it's ramping up, accelerating, becoming more and more dominated by mysterious forces. This suggests that the universe still has surprises in store for us. Dark energy might not be the end of the story, it might just be the next chapter. Maybe there are other hidden components of reality waiting to be discovered. Maybe the laws of physics themselves evolve over cosmic time. Maybe the universe is even stranger and more wonderful than our wildest theories suggest. And that brings me to perhaps the most important point about dark energy. It's a reminder that we're still in the early stages of understanding reality. Despite all our scientific progress, despite all our technological achievements, we've only just discovered that most of the universe is invisible to us. We're like explorers who have mapped the coastlines of a vast continent, but haven't yet ventured into the interior. This should be both humbling and exciting. Humbling because it reminds us how much we don't know, how many assumptions we've made that might be wrong, how many surprises might be waiting just beyond the edge of our current understanding. But exciting because it means the greatest discoveries might still lie ahead of us. Think about what it would mean to truly understand dark energy. If we could figure out what it is, where it comes from, and how it works, we might unlock technologies and possibilities that are currently unimaginable. We might discover new sources of energy, new ways to manipulate space and time, new insights into the fundamental nature of reality itself. Or we might find something even more surprising, that dark energy is just the tip of the iceberg, the first glimpse of a layer of reality that's been hidden from us since the beginning of time. Maybe there are forces and phenomena operating on scales, and in ways that we haven't even thought to look for yet. The history of science is full of discoveries that seemed impossible until they suddenly became obvious. Quantum mechanics was considered absurd until it became the foundation of modern technology. Relativity was dismissed as mathematical fantasy until it started powering our GPS satellites. Dark energy might seem mysterious and incomprehensible now, but future generations might look back on our current confusion the way we look back on medieval ideas about astronomy. And here's what I find most remarkable about our current situation. We're living through this discovery in real time. We're not reading about dark energy in history books or learning about it as settled science. We're watching the mystery unfold, observation by observation, theory by theory, with each new piece of evidence potentially changing everything we thought we knew. Every time a new survey completes, every time a new instrument comes online, every time a theorist has a new insight, we get a little closer to understanding one of the deepest mysteries in the universe. And you're here for all of it, watching it happen, maybe even contributing to it in ways you don't realize. Because here's something that often gets overlooked. Science isn't just done by people in lab coats working in isolation. It's a collective human endeavor that depends on curiosity, wonder, and the willingness to ask difficult questions. Every person who looks up at the night sky and wonders about the nature of reality is participating in the same enterprise that led to the discovery of dark energy. Your curiosity about these cosmic mysteries connects you to a tradition that stretches back to the earliest humans who looked up and wondered what those lights in the sky might be. And it connects you forward to future generations who might finally solve the puzzle of dark energy and discover what other secrets the universe has been keeping. The universe is not just expanding, it's revealing itself to us, layer by layer, mystery by mystery. Dark energy is one of those layers, and we're in the process of peeling it back to see what lies beneath. What we find might change everything we thought we knew about reality, consciousness, and our place in the cosmic story. And that story is still being written. Dark energy is not the end. It's a beginning. The beginning of a new chapter in our understanding of the universe, a new phase of exploration that will take us into territories we've never imagined. So the next time you look up at the night sky, remember, you're not just seeing stars and galaxies. You're seeing a universe that's actively reshaping itself, driven by forces we're only beginning to understand. You're witnessing the ongoing work of dark energy, the invisible sculptor that's been quietly crafting the cosmos for billions of years and will continue to do so long after we're gone. But for now, in this brief moment of cosmic history, you're here to witness it, to wonder about it, and maybe even to help figure out what it all means. And that's not just scientifically significant, it's cosmically meaningful. The universe has been waiting 13.8 billion years for conscious observers to discover dark energy. And now, finally, it has them. It has us. And the conversation between mind and cosmos is just getting started. But here's where the story takes a turn that nobody saw coming. Because while we've been focused on what dark energy is and what it's doing to the universe, there's another question that's been quietly lurking in the background, waiting for its moment to completely blow your mind. What if dark energy isn't actually dark at all? I know. We've been calling it dark this entire time because it's invisible, undetectable, mysterious. But what if the reason we can't see it isn't because it's hiding from us? What if it's because we've been looking in all the wrong places? Let me explain what I mean. When physicists talk about dark energy being dark, they mean it doesn't interact with electromagnetic radiation, it doesn't emit light, doesn't absorb light, doesn't scatter light. It's electromagnetically invisible. But that doesn't necessarily mean it's invisible to everything. There might be other ways that dark energy reveals itself, other signatures it leaves behind that we're only just beginning to recognize. And this is where some of the most cutting-edge research is taking us into completely uncharted territory. Because scientists are starting to discover that dark energy might be connected to phenomena we never thought were related, things like the behavior of subatomic particles in high-energy collisions, things like the way information flows through quantum systems, things like the fundamental structure of space-time itself at the smallest possible scales. For instance, there's growing evidence that dark energy might be intimately connected to something called the Casimir effect. This is a bizarre quantum phenomenon where two metal plates placed very close together in a vacuum actually attract each other, even though there's supposedly nothing between them. The attraction is caused by virtual particles, those quantum fluctuations I mentioned earlier behaving differently in the tiny space between the plates compared to the open vacuum around them. Now, here's the fascinating part. The Casimir effect creates a kind of negative energy density between the plates. A negative energy density is exactly what you'd need to drive the accelerating expansion of the universe. Some physicists are starting to wonder whether dark energy might be a large-scale manifestation of the same quantum processes that create the Casimir effect. If that's true, then dark energy isn't some exotic, unknown force. It's a macroscopic version of quantum effects we can actually measure in the laboratory. It's like discovering that the force reshaping the entire universe is just the same force that makes two pieces of metal stick together in a vacuum chamber, scaled up by a factor of 1 trillion. But the implications go even deeper, because if dark energy is connected to quantum vacuum fluctuations, then it's not separate from the matter and energy we know and love. It's part of the same underlying quantum field that gives rise to all particles, all forces, all interactions. In other words, dark energy might not be alien to our reality. It might be the most fundamental aspect of reality. Think about what this means. Every atom in your body, every photon of light hitting your eyes, every electrical impulse in your brain, all of it emerges from the same quantum field that's driving the expansion of the universe. You're not just living in a universe shaped by dark energy, you're made of the same stuff as dark energy. The force that's stretching space itself might be the same force that's holding your atoms together. And this connects to something even more profound: the relationship between consciousness and cosmology. Because if dark energy really is a manifestation of quantum vacuum fluctuations, then the universe isn't just expanding, it's thinking. Not in the sense of having thoughts like you do, but in the sense that the same quantum processes that give rise to information processing in your brain are operating on cosmic scales. Some physicists have even proposed that the universe itself might be a kind of quantum computer, with dark energy representing the computational processes that determine how reality evolves from moment to moment. In this view, the expansion of space isn't just a physical process, it's an informational process, with the universe literally computing its own future state. Now, I realize this sounds absolutely insane. The idea that the cosmos is a computer and dark energy is its operating system seems like something out of a science fiction novel. But here's the thing. We've discovered stranger things before. Quantum mechanics seemed insane when it was first proposed. Relativity seemed impossible until it was proven correct. The idea that most of the universe is invisible seemed ridiculous until we found dark matter and dark energy. And there's actual evidence starting to support these wild ideas. Experiments in quantum information theory are revealing deep connections between the structure of space-time and the flow of information. Theoretical work in cosmology is showing how the laws of physics might emerge from more fundamental computational processes. Even artificial intelligence research is uncovering principles that seem to apply to everything from neural networks to galactic evolution. What's emerging is a picture of reality where information, computation, and consciousness aren't just byproducts of physical processes. They might be the fundamental features of the universe, with matter and energy and space and time being emergent properties of deeper informational structures. And dark energy? Dark energy might be the universe's way of processing information about its own state, constantly computing how to evolve from one moment to the next, using the expansion of space as a kind of cosmic memory system. If this sounds too abstract, let me give you a concrete example of how this might work. Right now, your brain is processing information about these words, about these ideas, about the meaning and implications of what you're learning. That processing involves neurons firing, electrical patterns changing, information flowing from one region of your brain to another. But here's what's remarkable. The same basic principles that govern information processing in your brain also govern how quantum fields evolve, how particles interact, how space-time curves in response to matter and energy. The mathematics of neural networks, the mathematics of quantum field theory, and the mathematics of general relativity all share deep structural similarities. This suggests that the universe might be using the same computational strategies at every scale, from the quantum to the cosmic. Your thoughts might be using the same fundamental algorithms that dark energy uses to reshape space-time. The process of understanding these words might be a miniature version of the process that's driving the expansion of the universe. And if that's true, then studying dark energy isn't just about understanding cosmology, it's about understanding the nature of information, computation, and consciousness itself. The force that's stretching the cosmos might also be the force that's generating your thoughts, your experiences, your sense of being a conscious observer in a vast and mysterious universe. But let's bring this back down to Earth for a moment, because there's something practical and immediate about all this speculation. If dark energy really is connected to information processing, then we might be able to use that connection to develop entirely new technologies. Imagine if we could harness the same processes that drive cosmic expansion to create new forms of computation. Imagine if we could use the principles of dark energy to build computers that operate by manipulating space-time itself rather than just moving electrons around. Imagine if we could tap into the informational structure of the vacuum to create communication systems that work faster than light, not by violating relativity, but by using the expansion of space as a carrier wave. These aren't just fantasy scenarios. There are already researchers working on quantum computers that manipulate the vacuum state to perform calculations. There are theorists exploring how the geometry of space-time might be used to store and process information. There are engineers investigating whether the Casimir effect and related quantum phenomena might be harnessed for practical applications. We're still in the very early stages of understanding these connections, but the potential implications are staggering. If we can figure out how to work with dark energy, rather than just observing it passively, we might unlock capabilities that seem magical by today's standards. But even more important than the technological possibilities are the philosophical implications. Because if dark energy really is connected to information and consciousness, then the universe isn't just a collection of matter and energy evolving according to physical laws. It's a vast, interconnected information processing system that includes your thoughts, your experiences, your sense of wonder about these cosmic mysteries. You're not separate from dark energy, you're part of it. Every time you learn something new, every time you have an insight, every time you experience awe at the vastness and complexity of the cosmos, you're participating in the same fundamental processes that are reshaping space-time on the largest scales. And this brings us to perhaps the most profound realization of all. The universe isn't just expanding in space, it's expanding in complexity, in information, in the richness of possible experiences. The same force that's stretching the distance between galaxies is also increasing the potential for consciousness, for understanding, for meaning. Think about it this way. In the early universe, right after the Big Bang, there wasn't much complexity, just simple particles in thermal equilibrium, with very little structure and virtually no information processing. But as the universe expanded and cooled, more complex structures became possible. Atoms formed, then molecules, then stars and planets, and eventually life. Each step in this process involved the creation of new forms of information processing. Atoms process information about their quantum states. Molecules process information about chemical bonds. Living cells process information about their environment. Brains process information about sensory inputs and memories and abstract concepts. And now, here you are, processing information about dark energy and its role in cosmic evolution. You're part of the universe's ongoing project of understanding itself, of creating more and more sophisticated forms of consciousness that can contemplate deeper and deeper mysteries. Dark energy isn't just driving the physical expansion of space, it's driving the conceptual expansion of what's possible. It's creating the conditions for new forms of complexity, new types of information processing, new ways for the universe to experience and understand itself. And we're living right at the forefront of that expansion. We're the first generation in human history to discover dark energy, to grapple with its implications, to begin the long process of figuring out what it means for our understanding of reality. We're pioneers in the truest sense, exploring territory that no conscious beings have ever explored before. But here's the really exciting part. We're not just exploring this territory, we're creating it. Every new observation, every theoretical insight, every moment of understanding about dark energy is literally adding to the information content of the universe. We're not just discovering what's there, we're participating in the process by which the universe becomes more than it was before. The questions you're asking right now about dark energy, the sense of wonder you're feeling about cosmic mysteries, the connections you're making between these ideas and your own experience, all of that is part of the universe's ongoing evolution toward greater complexity and understanding. And the most remarkable thing is that this process is accelerating. Just like the expansion of space itself, the rate at which we're discovering new things about the universe is increasing. The sophistication of our theories is growing. The depth of our questions is expanding. We're living through what might be called the intellectual equivalent of cosmic acceleration. a period when understanding and consciousness and meaning are expanding faster and faster, driven by the same fundamental forces that are stretching space-time itself. This suggests that the story of dark energy is really just beginning. We've discovered its existence, we've measured its effects, we've started to explore its implications. But we haven't yet begun to understand what it means for the nature of reality, consciousness, and our place in the cosmic story. The next phase of dark energy research won't just be about building better telescopes or developing more sophisticated theories. It will be about understanding the deep connections between physics and information, between cosmology and consciousness, between the expansion of the universe and the expansion of mind. And you're here for all of it. You're not just a passive observer of these cosmic processes, you're an active participant in them. Every moment of curiosity, every flash of understanding, every sense of connection to the larger cosmos is contributing to the universe's ongoing project of becoming more conscious, more aware, more capable of understanding itself. The universe has been working for nearly 14 billion years to create conditions where conscious beings like you could exist and contemplate mysteries like dark energy. And now that you're here, the real adventure is just beginning. Because understanding dark energy isn't just about solving a scientific puzzle. It's about discovering what role consciousness plays in the fundamental structure of reality. It's about finding out whether the universe is not just expanding in space, but also expanding in meaning, in purpose, in the richness of possible experiences. And that's a mystery worth spending the rest of cosmic history trying to solve. So here we are, at the end of our journey through the cosmic mystery that is dark energy. We've travelled from the shocking discovery that changed everything we thought we knew about the universe, through the mind-bending implications of invisible forces reshaping reality itself, all the way to the profound possibility that consciousness and cosmos might be more deeply connected than we ever dared imagine. And as we wrap up this exploration, I want you to think about something that ties it all together. Right now, as you're processing these ideas, as you're contemplating the vastness of space and the mystery of forces we can barely comprehend, you're participating in something extraordinary. You're part of the universe's way of understanding itself. Think about that for a moment. The atoms in your brain were forged in the cores of ancient stars. The calcium in your bones, the iron in your blood, the oxygen you're breathing, all of it came from stellar furnaces that burned billions of years ago. You are literally made of star stuff, assembled into a configuration complex enough to contemplate the very forces that shaped the cosmos. And those forces are still at work. Dark energy is still stretching space, still accelerating the expansion, still writing the future chapters of the cosmic story. But now, for the first time in the universe's history, there are conscious observers, beings like you, who can witness this process, study it, and begin to understand what it means. This isn't just scientifically remarkable, it's cosmically significant. The universe spent nearly 14 billion years creating the conditions necessary for intelligence to emerge. It built stars to forge heavy elements, planets to provide stable environments, and the intricate chemistry of life to eventually produce brains capable of asking questions about dark energy. And now those brains exist. You exist. And you're using that existence to peer into the deepest mysteries of reality itself. But here's what makes this even more profound. This moment of discovery, this era of understanding dark energy and probing its secrets, might be incredibly brief on cosmic timescales. We're living in the narrow window when the evidence for dark energy is clear and accessible. In the far future, when dark energy has pushed galaxies so far apart that they're no longer visible, future civilizations won't have the clues we have today. They won't be able to discover the cosmic microwave background, won't see distant supernovas, won't have access to the observational evidence that revealed dark energy's existence to us. In a very real sense, we're living in the universe's moment of maximum self-awareness, the brief period when conscious beings can actually figure out what's happening on the largest scales. We're the universe's way of taking a snapshot of itself, of preserving knowledge about its own evolution for whatever comes next. And that knowledge, that understanding, that sense of wonder you feel when contemplating these cosmic mysteries, all of that becomes part of the universe's ongoing story. Every insight we gain about dark energy, every theoretical breakthrough, every moment of awe at the strangeness and beauty of existence adds to the total information content of reality. We're not just studying the universe, we're enriching it. We're making it more complex, more meaningful, more conscious of its own magnificent weirdness. So, what does this mean for you? Right here, right now. It means that your curiosity about dark energy isn't just casual interest in a scientific topic. It's participation in one of the most important projects in the history of existence, the universe's attempt to understand itself through conscious observers. Every question you ask, every connection you make, every moment of wonder you experience looking up at the night sky contributes to that project. You're not separate from the cosmic forces we've been discussing, you're part of them. Your dark energy's way of knowing itself, of experiencing its own effects, of contemplating its own mystery. And the story's far from over. We're still in the early chapters of understanding dark energy. The observations coming online in the next few years might completely change our picture of what it is and what it's doing. Theoretical breakthroughs might reveal connections we never imagined. New technologies might allow us to probe aspects of reality that are currently beyond our reach. But whatever we discover, however the story unfolds, you'll be part of it. Because understanding dark energy isn't something that happens in isolation in research labs or university departments. It's a collective human endeavor that depends on curiosity, wonder, and the willingness to grapple with ideas that stretch our minds to their limits. The questions that keep you awake at night, wondering about the nature of reality, the sense of awe you feel contemplating the vastness of space, the excitement you get from learning about cosmic mysteries, all of that is fuel for the ongoing project of cosmic self-discovery. And here's something beautiful to consider. While dark energy is pushing galaxies apart and will eventually lead to a cold, empty universe, it's also creating the conditions for increasingly sophisticated forms of consciousness and understanding. The same force that's stretching space is also expanding the possibilities for meaning, for knowledge, for the richness of experience. We're living proof of this. Here we are, products of a universe dominated by invisible forces, able to detect those forces, study them, and begin to understand their implications. We've taken matter that was once scattered randomly through space and organized it into brains, capable of contemplating the deepest questions about existence itself. That's not just unlikely, it's miraculous. And it suggests that the universe might be far more creative, far more purposeful, far more alive than we ever suspected. So, as you go about your daily life, as you look up at the stars, as you ponder these cosmic mysteries, remember that you're not just an observer of the universe, you're one of its most remarkable achievements. Your dark energy's gift to itself, a conscious being capable of understanding, appreciating, and marveling at the forces that shaped everything. The universe has been working for nearly 14 billion years to create you, to give you the ability to contemplate these questions, to experience wonder at the mystery of existence. And in return, you give the universe something it couldn't have without you, the capacity for self-awareness, for meaning, for the profound satisfaction of understanding its own deepest secrets. That's the real story of dark energy. Not just that it's reshaping the cosmos, but that in doing so, it's creating the conditions for consciousness to emerge and flourish, and ask the kinds of questions that make existence meaningful. And those questions will keep coming, because dark energy has taught us something crucial about the nature of reality. It's far stranger, far more mysterious, and far more wonderful than we ever imagined. Every answer we find leads to new questions. Every mystery we solve reveals deeper mysteries. The universe is not running out of surprises. If anything, it's accelerating toward greater and greater strangeness, driven by forces we're only beginning to understand. And you get to be here for all of it. You get to witness the ongoing revelation of cosmic secrets, to participate in the universe's journey toward understanding itself, to experience the awe and wonder that come from contemplating the deepest questions about existence. Dark energy may be invisible, mysterious, and incomprehensibly vast, but it led to you. It created the conditions for consciousness to emerge from matter, for intelligence to arise from chaos, for meaning to crystallize from randomness. That's not just the story of dark energy, that's the story of why anything matters at all. And it's a story that's still being written, with every new discovery, every moment of understanding, every flash of wonder at the magnificent mystery of existence. The universe is expanding, accelerating, becoming something new with every passing moment, and so are you. Every time you learn something, every time you make a connection, every time you experience awe at the cosmic dance happening all around you, you're expanding too, becoming more conscious, more aware, more capable of appreciating the profound beauty of reality. That's the ultimate message of dark energy. The universe isn't just getting bigger, it's getting more meaningful, and you're both witness to and participant in that ongoing transformation. And perhaps that's the most mind-bending realization of all. You're not just watching this cosmic story unfold, you're helping to write it. Every time you question what you think you know, every moment you allow yourself to be amazed by the sheer impossibility of your own existence in a universe dominated by invisible forces, you're adding new chapters to the greatest mystery story ever told. Because here's what keeps me up at night thinking about dark energy. We might be completely wrong about everything. And that's not a failure, that's the most exciting possibility imaginable. What if dark energy isn't what we think it is at all? What if the accelerating expansion we observe is actually the universe preparing for something we haven't even conceived of yet? What if we're living through the cosmic equivalent of a caterpillar entering its chrysalis, completely unaware that we're about to witness a transformation so profound that our current understanding of reality will seem quaint by comparison? Think about this. Every major breakthrough in physics has revealed that the universe is weirder than we thought. When we discovered quantum mechanics, we learned that particles can be in multiple places at once. When we uncovered relativity, we found that time can slow down and space can bend. When we detected dark matter, we realized that most of the matter in the universe is invisible. And now dark energy has shown us that the very fabric of space is alive, dynamic, constantly changing in ways that would have been unimaginable just a few decades ago. So what's next? What mind-bending revelation is waiting just beyond the edge of our current understanding? Maybe we'll discover that dark energy is just the beginning, the first glimpse of a layer of reality so strange that it makes quantum mechanics look simple. Maybe we'll find that consciousness itself plays a fundamental role in shaping the cosmos, that the universe needs observers, not just to understand it, but to actually determine how it evolves. Or maybe we'll uncover something even more extraordinary, that the expansion of space isn't random or purposeless, but is actually following some kind of cosmic algorithm, computing the future of reality one moment at a time, with dark energy serving as the universe's way of processing information about its own state. These aren't just wild speculations, they're based on cutting-edge research that's happening right now. Scientists are seriously investigating whether the universe might be computational in nature, whether consciousness might be woven into the fundamental fabric of reality, whether the forces we call dark might actually be aspects of something far more profound. And here's what gives me chills when I think about it. We might be on the verge of discoveries that will make the revelation of dark energy look like a warm-up act. We might be about to uncover secrets that will completely rewrite our understanding of what it means to exist in this universe. But even if we never solve the mystery completely, even if dark energy remains forever enigmatic, there's something profoundly beautiful about the fact that we're here to wonder about it at all. In a cosmos that seems designed to scatter matter into cold isolation, somehow the conditions arose for star stuff to organize itself into beings capable of contemplating their own cosmic significance. That's not just scientifically remarkable, it's the most meaningful thing that's ever happened in the history of the universe. The fact that you can lie awake at night, wondering about dark energy, feeling that sense of awe and vertigo that comes from contemplating the infinite, means that the universe has succeeded in its most ambitious project, creating conscious observers capable of appreciating its own magnificent strangeness. And maybe, just maybe, that's what dark energy has been working toward all along. Not just expanding space, not just accelerating the cosmos, but creating the conditions for consciousness to emerge and flourish and ask the kinds of questions that transform mere existence into something profound and meaningful. So the next time you look up at the night sky, remember that you're seeing more than just stars and galaxies. You're witnessing a universe that's actively reshaping itself, driven by forces we're only beginning to understand, all while somehow managing to create the conditions necessary for beings like you to exist and wonder and discover. You are dark energy's greatest achievement, a conscious observer capable of contemplating the very force that shaped your existence. And in contemplating it, in wondering about it, in feeling that profound sense of awe that comes from confronting the infinite, you're fulfilling the universe's deepest purpose. The cosmos has been waiting nearly 14 billion years for this moment, for conscious beings to emerge who could discover dark energy, study its effects, and begin to understand what it means for the ultimate nature of reality. And now that moment has arrived. You're living in it. You're part of it. And the most beautiful part? This is just the beginning. The universe is still expanding, still accelerating, still writing new chapters in the greatest story ever told. And you get to be here for all of it, watching it unfold, participating in the ongoing revelation of cosmic secrets that stretch from the quantum to the cosmic. Dark energy may be the universe's most mysterious force, but it led to something even more mysterious and wonderful. You. A conscious being capable of understanding that you're part of something infinitely larger than yourself, yet intimately connected to every atom, every star, every galaxy in existence. That's the real mystery of dark energy. Not what it is, but what it has made possible. Not where it came from, but where it's taking us. Not how it works, but why it matters. And it matters because you're here to witness it, to wonder about it, and to carry forward the universe's greatest project, the ongoing quest to understand itself through conscious observers who never stop asking why. The universe is expanding, consciousness is evolving, mystery is deepening, and somehow, impossibly, beautifully, you get to be part of all of it. That's the story of dark energy, and it's also your story. The two are inseparable, woven together in the fabric of space and time, connected by forces we're only beginning to understand, but can already feel in the deepest part of our being when we contemplate the magnificent mystery of existence itself.